Let's begin with the first question. What is an outlier? Odd values. So there is a difference between an outlier and normal data. And an outlier is a data object that deviates significantly from the normal objects. Yes, data out of rank or data far from popular one. Very good. We can consider noisy data as an outlier, or there is a difference? Now, so there is a difference between noise data and outliers. So outliers are different from the noise data. Why? Because noise is random error or variance in a measured variable. And normally we have to do what regarding noise data? Very good. So we have to remove all the noise data before outlier detections. So an outlier is interesting or not? We can consider an outlier an interesting thing. Yes, so outliers are interesting. So an outlier violates the mechanism that generates the normal data. Some applications of outlier. Can you give me some applications of an outlier? Fraud detection, yes. So credit card fraud detection is one of the applications of outlier. Yes. Network intrusion also can be considered as an application of an outlier. Telecom fraud detection, medical analysis. Yes. Very good. Let's move now to the next questions. What are the types of outliers? Types of outliers. Global outlier, yes. So global is one of the types of outliers. Also another type, contextual, very good. So contextual outlier is in the second type, and collective outliers is the third type. So for global outlier, how we can say that this outlier is global? So outlier is global if it deviates from the rest of the dataset, all the rest from the dataset. And for contextual outlier, so what is the difference between global outlier and contextual outlier? Global outlier deviates from the rest of the data, but contextual outlier deviates based on a select context. Yes. And collective outliers. Collective outliers. So a collective outliers are a subset of data or a group of outliers. And this group deviate from the whole data set. So we can find some individual data in this group that may not be an outlier, but all the group is an outlier. It is clear? So in a data set, we can find multiple types of outliers. in the same data set, we can find multiple types of outliers. We can find, for example, contextual, collective, and global. Yes or no? Yes. So a data set may have multiple types of outliers. And one object can belong to more than one type of outlier. In other words, the same object can be considered in the same time, for example, collective and the global. So yes, in one object may belong to more than one type of outliers. Okay. So we discussed also together the challenges of outlier detections. What are the challenges of outlier detection? So there are 4 challenges: modeling normal objects and outlier properly, application-specific outlier detection, handling noise and outlier detection, and understandability. 4 challenges. Let's move now to methods. So we discussed 6 manners or 6 methods to detect an outlier. Let's begin with the first type, supervised methods. How we can use supervised methods to detect an outlier. Are you here? Yes, classification. So, yes, very good. So, modeling outlier detection as a classification problem. So, classification problem, that means we want to create a model that classify our data into normal and outlier data. Good. After that, the second manner is unsupervised method. Unsupervised method. So how we can detect an outlier using unsupervised methods? Clustering, yes. So we will assume the normal objects are somewhat clustered into multiple groups and each having some distinct features. Very good. After that, semi-supervised methods. So, what is the situation that in this situation we can use semi-supervised method? If we have the number of labeled data is small. For example, if we have only only some labeled normal objects are available, in this case we will use the labeled examples and the proximate and labeled objects to train a model for normal objects, and those not fitting the model of normal objects are detected as outliers. And if only some labeled outliers are available, so a small number of labeled outliers may not cover the possible outliers well. And to improve the quality of outlier detection, one can get help from models for normal objects learned from unsupervised learning. Let's move now to the 4th manners to detect an outlier, or the statistical methods. So what's the meaning of statistical methods? How we can use statistical methods to detect an outlier? Any idea? So in statistical methods, there are two types, parametric and non-parametric methods, yes. But statistical methods assume that the normal data follow some statistical model, and the data not following the model are outliers. It is clear? So for example, in this example, we will calculate the probability of each object that fits the Gaussian distribution. And if the probability is very low, in this case, this object is unlikely generated by the Gaussian model. Thus, it will be considered as an outlier. And here in statistical methods, there are two types, parametric and non-parametric. Another method is a proximity-based method. So how we can use proximity-based methods to detect an outlier? So in proximity-based methods, there are two major types of proximity-based outlier detection. What are these types? Very good. So one of the manners is to measure the distance. So the types, the measure types here, there is distance-based and density-based. So an object is an outlier if the nearest neighbors of the object are far away. The proximity of the object is significantly deviates from the proximity of most of the other objects in the same data set. So for example, so this is an example. If we consider three nearest neighbors here, objects in the figure in the region R are different from other objects in the data set. Thus the objects in R are outliers. It is clear? Any questions? Now clustering-based methods. How we can use clustering-based methods to detect an outlier? So normal data belong to large and dense clusters, whereas outliers belong to small or sparse clusters, or do not belong to any clusters. For example, here in the right figure we have two clusters. All points not in R form a large cluster, and the 2 points in R from a teeny cluster. These are outliers. So also in face-to-face class we discussed statistical approaches here with parametric and non-parametric methods. So what is the difference between parametric method and non-parametric methods? So the difference that the parametric methods assume that the normal data is generated by a parametric distribution with a parameter. For this reason we said that these methods are parametric, and for non-parametric methods not assume an a priori statistical model and determine the model from the input data. This is the difference. In the parametric we assume that the model exists, and this model is with a parameter, and in non-parametric methods we assume that there is no model and we will determine the model from the input data. It is clear? Any questions about statistical approaches? Do you hear me? Okay, in proximity-based approaches also, we discussed the two types of proximity-based outlier detection methods, the distance-based outlier detection and the density-based outlier detection. And we said that in the distance-based outlier detection, an object O is an outlier if its neighborhood does not have enough other points. And in the density-based outlier, an object O is an outlier if its density is relatively much lower than that of its neighbors. In the clustering-based approaches, so clustering-based approach detection, an object is an outlier if, so here there are three possibilities. In the clustering, there are three possibilities. One, it does not belong to any cluster. This is the first possibility. Two, there is a large distance between the object and its closed cluster. Or the third possibility is it belongs to a small or sparse cluster. Is clear how we can use clustering-based outlier detections? So I repeat, there are three possibilities. Does not belong to any cluster. This is the first possibility. There is a large distance between the object and this closest cluster. This is the second possibility, or it belongs to a small or sparse cluster. Let's begin with the first case number one. Not belong to any cluster. For example, identify animals not part of a flock using a density-based clustering method such as a DB scan. So in the figure here, A, the object A, does not belong to the first cluster or to the second one. So A, it will be considered as an outlier. Let's move now to case number two. Far from its closed cluster. So using k-means partition data points of, yes, here in between, yes. So A cannot belong to the first cluster and nor to the second one. In the case number two, far from its closed cluster. When we use k-means, partition data points into clusters, and for each object O, assign an outlier score based on its distance from its closed center. So if the distance between O and the center of the cluster divided by average of the distance of all the distance is large, in this case we can say that this object can be an outlier. In other words, if we find an object far from its closed cluster, in this case this object can be considered an outlier. And to classify this object as an outlier, we can use the distance of this object and the center of the closed cluster divided by the average of all the distance of the same cluster. And if we find this distance is large, in this case we can say that this is an outlier. Is clear? Okay. For example, intrusion detection, we will consider the similarity between data points and the cluster in a training data set. We will use a training data set to find patterns of normal data, frequent item sets in each segment, and cluster similar connection into groups. We will compare new data points with the clusters mined, and outliers are possible attacks. So this is a concrete example to detect an intrusion. So clustering-based methods. Here, the strength of clustering-based methods, we will detect outliers without requiring any labeled data, work for many types of data. Clusters can be regarded as only compare any object against the clusters to determine it is an outlier. Weakness, so effectiveness depends highly of the clustering method used. They may not be optimized for outlier detection. Also the problem of computational cost. So clustering-based methods has a high computational cost, need to first find the clusters. And a method to reduce the cost we can fix with clustering. So a point is assigned to a cluster if the center of the cluster is within a predefined distance threshold from the point. And if a point cannot be assigned to any existing cluster, a new cluster is created and the distance threshold may be learned from the training data under certain conditions. Any questions? Let's move now to the last point of this chapter, classification approaches. So classification-based methods, one class model. Here we want to create a model with one class. The idea is to train a classification model that can distinguish normal data from outliers. A brute force approach, we will consider a training set that contains samples labeled as normal and other labeled as outliers. But the training set is typically heavily biased. That means the number of normal samples likely far exceeds the number of outlier samples. Here our data is an unbalanced data, cannot detect and see an anomaly. For this reason, one class model, so a classifier, is built to describe only the normal class. We will learn the decision boundary of the normal class using classification method, such as we can use the support vector machine methods. And any samples that does not belong to the normal class are declared as outlier. So the advantage can detect new outliers that may not appear close to any outlier objects in the training set. Extension, so normal objects may belong to multiple classes. It is clear, classification-based method with one class model. Any questions about this slide? Okay, this is the last slide in our course. Classification-based method with semi-supervised learning. Yes, this is not uploaded. Okay, I will upload it, but you can consider the study guide now. Semi-supervised learning, combining classification-based and clustering-based methods. This is the meaning of semi-supervised learning. So the method, we will use a clustering-based approach to find a large cluster C and a small cluster C1. Since some objects in C carry the label normal, treat all the objects in C as normal and use the one-class model of this cluster to identify normal objects in outlier detection. And since some objects in cluster C1 carry the label outlier, declare all objects in C1 as outliers, and any object that does not fall into the model for C is considered as an outlier. Comments on classification-based outlier detection methods. So the outlier detection is fast, but the quality here, the outlier detection is fast, but the quality heavily depends on the availability and quality of the training set, but often difficult to obtain representative and high quality training data. So in this chapter we discussed together how we can detect an outlier, how we can analyze an outlier, outlier and outlier analysis, outlier detection methods. We discussed supervised methods, unsupervised methods, semi-supervised methods, proximity-based approaches, and statistical approaches. Any questions about this chapter? Yes, of course. So for the final, you have to prepare all the content, and there is 30% for the content